Now we're looking at number 6 from 3.4 homework for geometry. We're given this triangle again, two inner triangles, and we are trying to prove that the two inner triangles, DEF and DEC, are congruent. And the way we're going to go about doing that is starting with our given information and marking up our diagram. It says DE is the perpendicular bisector of FC. Perpendicular bisector means that it is going to cut this right here, cut into this at a 90-degree angle. So first thing we're going to know is that these two angles are 90 degrees. Secondly, we're going to take our free information. Since we're trying to prove two inner triangles are congruent to each other, we have a shared side. We're going to say that that side is equal to itself. And we didn't finish going through our given information. It says DF is equal to DC. So DF is equal to DC. And we see here that we have angle, side, side, angle, side, side. But we know that that is not a valid form of congruence because it's possible to get two different triangles from angle, side, side congruence. So we do have to notice that these two equal angles are not just any equal angles, they are in fact right angles, making this a right triangle, both of these right triangles. And because of that, because it's a right triangle, we actually have a hypotenuse over here, and then we have a leg for both of these triangles of a right triangle. So we're going to try to prove that these two triangles are congruent by hypotenuse leg, HL. So let's go ahead and write that out now. First step, we take our given information and write down the freebies. Second step is to explain that these two angles not only are both 90 degrees, but in fact equal to each other. We have angle DEF and we have angle DEC. So angle DEF is equal to angle DEC, and both of them are equal to 90 degrees. Throw a little degree symbol in there. Both of them are 90 degrees, and because they're both 90 degrees, they are both therefore equal to one another. And I can simplify that by writing it in one step. And the reason I can do that is by the definition of perpendicular. So I told it was a perpendicular bisector. All I really needed to know in that case was the fact that we have perpendicular lines, so that these two angles form 90 degrees. Third step, once I have both of that, is identifying that DE is equal to itself by the reflexive property. So we have that formally written down. DE is equal to DE. Again, that's reflexive. And once we've done that, we've established everything we need for hypotenuse leg. We have our hypotenuse, we have our legs that are equal, and we have a right triangle. Both of them are 90 degrees. So I can go ahead and make the statement that DEF, that triangle, is in fact congruent to DEC. I have to make sure I get my order right. DEF, DEC, and that follows the corresponding part. So I am good to go there and get my symbols right here, throw my little triangles out front, and make this a statement of congruence. The reason I can do that, HL, hypotenuse leg.